Hey guys, welcome to our next online lesson. This time we're going to talk about decimals and we're going to get into comparing numbers. First, there are two types of decimals we need to know. Terminating decimals and repeating decimals. Let's start with terminating decimals. Say I gave you a fraction like 1/5 and I asked you to convert that to decimal form. Well, of course, we know to take the numerator, put it inside the house, divide it by the denominator, which in this case is 5. 5 cannot go into 1, so we can put a 0, annex our decimal place, and annex a 0. How many times can 5 go into 10? The answer is 2. 2 times 5 is 10. Subtract, and we're left with 0. No remainders, and that's what's called a terminating decimal, meaning that it stops, it's over. We know that 1/5 is equal to 2/10. Terminating decimal. It stops. On the other hand, let's talk about repeating decimals. And if I give you a fraction like -4/11, and I asked you to convert that into a decimal, you'd do it the same way. You would take the numerator, 4, put it inside the house. Our denominator, 11, goes outside. Bear in mind that it is a -4/11. So we're going to have to put our negative sign here, just so we know that whatever decimal we come up with, it is going to be a negative decimal. Let's go back to dividing. 11 cannot go into 4, so we put our 0. We will annex the decimal place and annex a 0. Now, how many times can 11 go into 40? Well, it can't go evenly, but the closest it can is 3. 3 times 11 is 33. Subtract. 40 minus 33 is 7. Okay, we have a remainder. We'll annex a 0, bring it down. How many times can 11 go into 70? It can't evenly, but the closest it can is 6. 6 times 11 is 66. Subtract. 70 minus 66 is 4. Okay, again a remainder. So let's annex a 0, bring it down. And how many times can 11 go into 40? Well, it can't evenly, but the closest it can is 3. 3 times 11 is 33. Subtract. 40 minus 33 is 7. By now, you're probably noticing that there's a pattern happening. We're left with a remainder. 0, bring it down. How many times can 11 go into 70? Well, we just did that up here. It can't go in evenly, but the closest it can is 6. 6 times 11 is 66. Subtract. 70 minus 66 is 4. I think we see a pattern. That if I kept on dividing, I would keep getting 3, 6, 3, 6, 3, 6, 3, 6, and I could keep going on and on and on with 3, 6. That's what makes it a repeating decimal. It doesn't end, it just keeps repeating. Now, how do I write that, though, as a decimal? Well, -4/11. The decimal form is a -0.36. What I do is I put this in bar notation. And what that means is I just put a little line over the part that repeats. In this case, 3, 6, 3, 6, 3, 6. Just will keep repeating on and on and on. So what I do is I designate it with a bar on top to let you know that the 3, 6 repeats. So again, when you see the bar on top, it just means that part keeps repeating. Now, if I can find my eraser, there it is. There's a couple more definitions that we need to get down. There seems to be a little bit of confusion in class with less than, greater than, or equal to. So I want to make sure we have these down in our notes. Blank is read as less than. It's the alligator eating this way. That is read as less than. A way to remember is it kind of looks like an L. L-E-S-S. It's eating that way, it's read as less than. This way is read as greater than. Blank is read as equal to. It is the equal sign. So please make sure in your notes you have these. There, again, seems to be some confusion in class when we talk about less than, greater than, equal to. So make sure we have those symbols down, please. Okay, let's go on to ordering. Oh, sorry, before we do that, I do have some tips for you. When you're comparing numbers, there's 2 tips that I think are going to help us tremendously. First, change the numbers to the same form. I like decimals. You could change them to percents. You could change them to fractions. Whatever it is, when you're comparing numbers, make sure you put them all in the same form. And the second tip, any negative number is smaller than any positive number. Please make sure in your notes you filled in the correct blanks in the words. Let's go on to compare. Okay, 3 sample problems I want to look at. The first is 4/5, and we need to know, again, when we compare, we're doing, is it less than, is it greater than, or is it equal to? So that's what we're filling in the little blanks here. 4/5 and 93/100. We need to compare them. My first tip was put them all in the same form. In this case, I have a fraction and I have a decimal. I like to change it into decimals, so let's do that. We need to change 4/5 to a decimal. So I take my numerator, which is 4, divide it by my denominator, which is 5. 5 goes into 4, it does not. So therefore, we annex our decimal place and annex a 0. And now how many times does 5 go into 40? The answer is 8. 8 times 5 is 40. Subtract, and we are at 0. Another perfect terminating decimal. So now, instead of 4/5, what we're comparing now is 0.8 to 0 and 93/100. Okay, because we're comparing hundredths to tenths here, I can go ahead and annex a 0 there, so it's really 80/100 to 93/100. So let's go ahead and compare. 0 and 0, they're the same. Let's look at the next place. Ooh, I see an 8 and a 9. I could stop right there because I know 9 is greater than 8. So therefore 93/100 is greater than 80/100. 4/5 is equal to 80/100. So therefore we know 93/100. 4/5 is less than 93/100. Let's look down here at this example. -8 and 2. They're in the same form. They're both are integers in the same form. Now which one's greater? Well, if you remember my second tip, any positive number is greater than any negative number. So right away we know 2 is greater than -8. Let's look up here. I have 1 and 40/100 and 1 and 1/4. I don't really like the way this came out, so I'm going to write 1 and 1/4 there. Again, we need to get them into the same form, and I like decimal form. This one's already in decimal form, so we're going to leave it that way. 1 and 1/4. We know it's going to be the whole number 1, so we can leave that there. So let's find the decimal form of 1/4. I take my numerator 1, put it inside the house. My denominator 4 goes on the outside. 4 cannot go into 1 evenly. I add my decimal, I add my 0. Now how many times does 4 go into 10? The answer is 2. 2 times 4 is 8. I subtract. 10 minus 8 is 2. We have a remainder, so let's annex a 0. Bring it down. How many times does 4 go into 20? The answer is 5. 5 times 4 is 20. Perfect. We'll pause right there because we have no remainders. And our decimal place is decimal point 25. Remember, we just took the 1, left it as the whole number 1. And we figured out 1/4 is actually equal to 25 hundredths. So we brought that down there. So really comparing is 1 and 40 hundredths to 1 and 25 hundredths. So let's compare. The ones place, it's the same. Move to the tens place. I see a bigger number. 4 is definitely bigger than 2. So therefore, it's going to be greater than. And I slide my greater than symbol right there. 1 and 40 hundredths is greater than 1 and 1/4. Remember, the tip is to change them all to the same form. Now, I want to leave you with some sample problems to try on your own. I gave you 3 problems. What I want you to do is on your own try these. And tomorrow at group, what we'll do is we'll first go over these questions and then we'll go on to some more examples. But for the first 2, it says write the fraction as a decimal. Use bar notation if necessary. What that means is if it's a repeating decimal, put the bar on top to let me know what part repeats. Another tip that I'll do is I'll ask you to go at least 3 decimal places. Please go at least 3 decimal places if you think it's going to repeat. Don't just stop at 1 and say, oh, it's going to repeat. Go at least 3 decimal places to figure out if, in fact, it does repeat. Also, here's another tip. That's a negative number, so please make sure your decimal is negative. For this one here, I want you to use the greater than, less than, or equal to symbols to make that statement true. Complete these 3 problems, and we'll see you in class. Thank you.